Good morning, students. Today we will be looking into this chapter of climatology, that is the fourth fold of climatology, and the name of the chapter is Air Fronts and Extratropical Cyclones. So both of them are separate chapters, but since they are having important information that needs to be shared. They are interrelated to each other. So combined the two. So I am Astha, and I shall be giving you this information on air fronts, what are air fronts, how they are classified, and how they are formed. And later on, we will be also looking into extratropical cyclones, what these cyclones are, where they are found, formed, and what are the necessary conditions, what are their characteristics. We shall be looking into all of these things. So first, we will start with air fronts and how they are interrelated with extratropical cyclones, because the creation of fronts is very important for the creation of a cyclone, for the origin of a cyclone. So that is why these two have been combined together in this presentation. I hope it will be helpful for you for gaining knowledge and for better understanding of your study material. Okay, so when we will be discussing about air fronts, we will be basically looking into the frontogenesis process as well as the frontolysis process. What are these processes? I will be telling you. First of all, let me tell you what is a front. How do we define a front? How do we identify a front? So basically, a front is a three-dimensional, that is a 3D boundary zone. It is also like a surface. So it is like a sloping surface. It is like a gently sloping surface, or it may even have a steep slope, depending upon the conditions and the what type of a front it is, which air mass does that front belong to. Depending upon these details, the front is formed, and the front is generally, it is a three-dimensional. When I say three-dimensional, I basically mean that it has a length, it has a breadth, that means it has a width, and it also has a height. So that makes it 3D. Okay, now when I talk about a front, I should also be telling you that it is very important for the presence of air masses to be there in order to create a front. If there are no air masses, then there will be no creation of any fronts. So air masses are required. Air masses lecture, we have already, in the air masses lecture, we have already discussed what are the different types of air masses, the source regions of air masses, how they originate, how they are classified. All this has been given to you in the form of a video lecture. So we will not, I will not give you a lot of detail about the air masses, since it has already been covered in a previous lecture. So in this lecture, let us concentrate on the fronts, the process of frontogenesis and frontolysis, whatever they are, whatever the meaning they contain, how they are defined, all that will be given to you in this lecture. Okay, so now I want to also tell you, when I am talking about a front, I am basically talking about two air masses. And these two air masses are not homogeneous. If I say homogeneous, that means similar in characteristics. So these are not similar, they are dissimilar. That means they are heterogeneous, they are opposing in nature. They are having a contrasting nature. So when they have a contrasting nature, when two air masses, when they are opposing in nature, that means they have different characteristics. They are different from each other in terms of temperature, in terms of moisture content, in terms of lapse rate, wind speed, wind direction, all these things. These are the different characteristics. All these define the air mass. Fine. So when I say temperature, that means it can be a cold air mass and a hot air mass or a warm air mass. So these things need to be considered while understanding what a front is. Now, when I say air masses, I also want to tell you that both the air masses, they are coming from different directions and they come closer to each other. They come face to face with each other in such a manner that they develop a front in between. It can be similar to a warring front where on earth where two armies of different nations, so they are opposing armies. That means they have come to fight over there. One army has to occupy a dominant position. One of the armies is more powerful and it occupies a dominant position and it tries to capture the other army and the other army's territory. So over here also, the same thing is happening. When I say a front, this is not like a warring front that we see in a battlefield or on a war zone, but this is basically happening in the atmosphere. And when I say the atmosphere, that means it is happening above the ground. And in the atmosphere, there are several weather conditions that are taking place. There are certain conditions which are also associated with the formation of the fronts. So when there are different fronts that are forming, there are different types of fronts. We will be looking into that also. And so when I say different types of fronts, there are different weather conditions which are associated with different types of fronts. So we will look into that a little later on, but as of now, let me tell you that these fronts, these are neither parallel to the ground, nor they are vertical or perpendicular to the ground. So they are neither vertical, that means they are not standing on the ground, they are not vertical to the ground, neither are they parallel to the ground. So what are they basically? How can they be identified? They are inclined at a low angle. When I say a low angle, that means they are sloping. They have a slanting appearance. That is why they are known as inclined to the earth at a low angle. So this is about a front. That is, it is 3D. It is having a boundary. It has a sloping surface, and it has a three-dimensional appearance. Also, it is only formed when two air masses are opposing in nature. Like I gave you the example of a warring front on the ground. Similarly, the two air masses are doing the same thing, but they are not doing it on the ground, they are doing it in the atmosphere. One of the air mass tries to occupy a dominant position, it becomes more forceful, more powerful, and it tries to occupy the area that is covered by the another air mass. Okay, so this thing needs to be understood very well, that two air masses, one air mass will be hot and another air mass will be cold. Both of them will have different characteristics, different wind speed, different directions they are coming from. They have different moisture absorbing capacities and they have different moisture content as well. So these are the different things that both the air masses need to have in order to create a front. Two same air masses cannot create a front. They have to be different in characteristics. They have to be contrasting in nature. Okay, now a front. When I say a front, this front basically, it is not like a point on the in the atmosphere. It is not like some area that is a small area, but it can be a large area. The front, whenever a front is formed, it can be a cold front, it can be a warm front. Cold fronts are formed by cold air masses, and warm fronts are formed by warm air masses. So these fronts, whenever they are formed, they are not small or they are not like a point. They cover a huge area. They cover a huge space. And when I say they cover a huge space, how much kilometers they occupy. How many kilometers? Around 5 to 80 kilometers is the aerial extent of the front. That means they can cover up to a distance of 5 to 80 kilometers. If it is a small front, if it is a beginning stage of the front, it will be small and it will cover a small distance. But if it is a larger front, it is a more powerful and a dominant front, then it will cover a larger distance. Okay. So this is about the information about the fronts and how there can be temperature differences, how the wind direction changes. It can lead to differences in the weather phenomena. Suddenly after the creation of the front, there can be creation of clouds, there can be condensation process that is taking place in the atmosphere, and then finally there will be precipitation. If it is a cold area, depending upon the temperature conditions, it will be precipitation will be in the form of snowfall. If it is not a very cold area and depending upon whatever front is being formed, then it will be rainfall. So different types of precipitation in the form of snowfall or rainfall or hailstorm or drizzle, any dews, all these things can happen in the whenever the precipitation is happening. But generally, precipitation is in the form of heavy downpour or at least moderate downpour. So, opposing air masses. Now, opposing air masses, when I talk about opposing air masses, I already told you these air masses are contrasting in nature. Contrasting means they have heterogeneous properties. They are not similar to each other. They are not the same. They have opposing characteristics. That means one is warm, one is cold, one can be humid, another can be dry, one can be having a different direction and a wind speed, one can be coming from east, another can be coming from the west. So these things are of great importance when I am telling you about the opposing air masses or air masses having a contrasting nature. That means there is a contrast, there can be comparison between the two. That is the meaning of contrast. Okay, at the time of convergence, they arrive from opposite directions. Definitely one is coming from one direction, eastern direction, another is coming from western direction, or one can be coming from north, another can be coming from south. So this is the different directions that they come from. Okay. This is one thing. Another thing is about the areas they come from. This is very important because when I say a cold air mass, so how will the air mass become cold? That means it has to come from a source region which is cold. So if the source region is cold, then it will lead to the origin of a cold air mass. If the source region is warm or hot, then it will lead to the creation of a warm air mass. So when I say cold air mass, that means it would be coming from the polar area. When I say a warm air mass, that means it would be coming from a tropical area or a warmer area, or maybe an equatorial area for that matter. So we'll not go into those details of air masses, but this is the general idea that you should know about from where the air masses would be coming, because pressure belts, air masses, fronts, cyclones, all these things are interrelated with each other. If we need to understand one thing, we also need to understand its the other aspects of those conditions which are influencing the each other. Okay, so let me tell you about the cold air mass. We have already learned about the cold air mass and its characteristics in the lecture on air masses, but just for a brief review or like a little revision I will give you. Cold air masses are stable air masses. Cold air masses are dry generally. Cold air masses are dense. Another thing about cold air masses is that they have a higher pressure because they are dense. They have a higher volume. They have a they tend to settle downwards. They tend to move downwards because of their heavier weight. They exert a heavy pressure. That means they have a higher pressure which is exerted by them on the surface of the earth. Okay. Now, this is very important over here because the cold air masses, because of their tendency to settle downwards, they are generally in a mode of friction with the Earth's surface. And the warm air masses. When I talk about the warm air masses, I basically am trying to tell you that warm air masses come from a warm source region. Warm air masses are lighter in weight. They have a tendency to rise upward into the atmosphere, and these warm air masses, they have a higher capacity of absorbing moisture from the oceans, from the seas. Okay, so they have a higher capacity of absorbing moisture. So they can be humid as well as dry depending upon the source region. If it is a continental source region, then they will be dry. If it is a maritime source region, then the air mass will be humid. So, but what is of importance over here is that warm air masses have a higher capacity to absorb moisture as compared to the cold air masses. Okay, now both these air masses, when they come face to face with each other, they are trying to occupy each other's position. They are trying to push one another and become more dominant. So there is a struggle between the two. There is a fight between the two. And whichever air mass becomes more powerful, that air mass is able to occupy the area of another air mass completely, to that extent that the other air mass as well as the front formed by that air mass is completely dissolved. It is completely weakened and it withers away. So this is of importance over here. This is what happens when both of them collide with each other, when both of them invade each other's territory. This is what happens. So when these air masses, they start diverging into different directions, the front begins to disintegrate and it is destroyed. So this is what happens. Now, front formation or frontogenesis. When I say front formation, basically I am referring to genesis. Genesis means origin. Genesis means birth. That means when I'm trying to inform you about the front formation or the process of frontogenesis, basically I'm trying to tell you how a front is being formed. How does it take birth? How does it originate? Okay. So the process of origination, the process of origin of a front, whether a cold front or a warm front, both these fronts are formed, and the process of their formation is known as frontogenesis. Okay, the process generally takes place when both the contrasting air masses, they come face to face with each other, they come in close proximity to each other, and they are trying to take each other's territory. I have already explained to you both these air masses. There is a competition between the two. Competition in the sense which one of the air mass will become more dominant and which air mass will become more powerful and occupy the other weaker air mass's territory. Okay. The process of frontogenesis, it takes place in an anti-clockwise direction in the northern hemisphere and in the clockwise direction in the southern hemisphere. This is important because why does it happen this way? Why anti-clockwise in the northern hemisphere? Why clockwise in the southern hemisphere? So we all know that there is equator, that is the line, that is the latitude which divides the earth into two equal halves. So the upper half is known as the northern hemisphere, the bottom half is known as the southern hemisphere. So what happens is that earth is continuously rotating on its axis. That is why we can see that there are nights and there are days. So after the night is over, the day arrives, and after the day is over, the night arrives. So this is a continuous cycle taking place in the universe, in the nature, and on planet Earth. So why is this happening? Why are days and nights caused? They are caused only because of the rotation of the Earth on its own axis. Now, there is another interesting thing that happens when the Earth rotates on its axis. What is that thing? That thing is the Coriolis effect. Coriolis effect is something which generates the Coriolis force. Okay, like there is friction, there is force of friction, there is force of gravity. Similarly, there is also a Coriolis force. This Coriolis force is only formed because of the rotation of the Earth on its axis. If the Earth will not rotate, then Coriolis effect will also not happen. So, because of this Coriolis force, there is a separate set of activity that is happening in the northern hemisphere and a separate set of activity that is happening in the southern hemisphere. Because this Coriolis force, it has a tendency of changing the direction of the winds. Okay, so as we cross the equator and move into the northern hemisphere, the wind direction changes and it moves in an anti-clockwise direction. And when we are moving below the equator in the southern hemisphere, this wind direction again changes and it is in the clockwise direction in the southern hemisphere. So this is only happening because of the Coriolis effect. This is important information for frontogenesis. Now, if by chance, we all know, okay, let me tell you this before I tell you another thing about frontogenesis. When we all know that there is nothing permanent. So because there is nothing permanent, everything is there for a specific amount of time, like human life is also there for a specific amount of time. We take birth and eventually we die. Similarly, it also happens with the plants, this also happens with the animals, it also happens with every other phenomena, everything that is taking birth, it also has to come to an end. So, like the formation of the fronts takes place, the origin and the birth of the fronts takes place by the process of frontogenesis, similarly, there is also a process by which the fronts have to come to an end. Okay, so this process is known as frontolysis. Fine. So decaying fronts, that is the last point I'm discussing now, the regeneration of the decaying fronts. That means those fronts which are already coming to an end, if by chance there are certain weather conditions which are helping the fronts to come away from their decaying stage, to come away from their process of frontolysis, then again, if there is any regeneration of the fronts, then that stage is also covered under the process of frontogenesis. Okay, because again, it is coming back from being destroyed, it is coming back from its end cycle. So again, there is regeneration, that is why there is a process of frontogenesis. Okay, now as I have told you, frontolysis, that means the end of the front. That means the collapse of the front. That means now this is the end stage of the front. After this, the front will dissipate, it will become weak, it will dissipate, it will dissolve, it will go away, and there will be no existence of the front anymore. So, When I'm talking about frontolysis, this is that situation where the fronts, they lose their significance, they become weak and they wither away. Okay, this process of weakening of the front and the end of the front, the death of the front, is known as the process of frontolysis. This process only takes place when one of the air mass has become completely dominant. One of the air mass has become so powerful that it has occupied the space of another air mass, and that it has completely occupied its space, it has completely destroyed that air mass's front, and now there is a weakening of that air mass's front. So there is the process of frontolysis. That means end of the fronts. Okay. Frontolysis is also that stage when the cyclone comes to an end. And when I'm talking about cyclone, I'm basically referring to the temperate cyclones. Okay. So these temperate cyclones, they come to an end when the process of frontolysis begins. Okay. Thereafter, the air masses start diverging. Excuse me. Thereafter, the air masses, they start diverging in different directions. In other words, frontolysis causes the divergence of the air masses. Divergence and convergence are two processes where we should understand that both these are opposite to each other. When I talk about convergence, I basically mean coming together at one central point. And when I talk about divergence, I am basically referring to moving away of the wind or the air from one central point. So, whenever the air masses, they start diverging in different directions, that means from one central point, when they move away from each other, when they go away from each other, and they move in different directions, then the fronts are destroyed and the frontolysis process begins. That means after frontolysis, divergence begins. Okay, now this is a diagram of the front. As I have told you, let me tell you again, front was the, what was the front that we have already discussed? It is a boundary, it is a 3D zone, it is like a sloping surface which is present in the atmosphere. It is created by the contrasting air masses like warm air and cold air. These are able to create fronts, and in this diagram, you can see this red color arrow is pointing upwards. This is the warm air. It is representing the warm air. And the blue color arrow, which is pointing in one direction, in the horizontal direction, this is representing the cold air, these blue color arrows. And this blue color line that you are seeing over here, this is a zone. What is this zone called? This is the 3D zone, which is the front. Okay. So this 3D zone or 3D boundary or sloping surface, slanting surface, this is known as the front. Okay. Now, since this is also blue in color, we can understand that this is a cold front. Okay, now air circulation and frontogenesis. Now, air circulation, basically when I'm talking about air circulation and frontogenesis, there is this person known as Patterson, and he has given us 4 types of air circulations, okay, that are happening in the atmosphere. Some of them are helpful for the creation of the fronts, some of them are not helpful for the creation of the fronts, but there are temperature differences when we talk about these circulations, like there is translatory circulation given by Patterson, rotatory circulation, convergent and divergent, and deformatory circulation. Okay, So these air circulations are given by Patterson, and he has tried to explain this with the help of a diagram also. Over here, we can see that this movement of air in A, that is the A first, that is the first box that you can see, it is labeled as A. Over here, we can see that it is showing translatory circulation. Okay, it is denoted by capital letter A over here. That means this is the first type of circulation we are referring to. That is the translatory circulation. This is moving of air in one direction, in a horizontal direction. Okay. Then there is B and C. Okay, B and C. This is the second and third type of circulation. That means the rotatory circulation. Okay. In this, we can see that B and C is rotatory, as the name is telling us. We can see that it is taking place in a rotation. It is happening in a rotation. That means it is happening in a circular movement. Okay. So that is why it is given the name of rotatory circulation. Then D and E, that is convergent and divergent. So D is showing us convergent circulation movement and E is showing us divergent circulation movement. I already explained to you that what divergent and convergent means. Basically, in convergent type of circulation, or in convergent type of movement, there is the air is coming from all directions and it is meeting at a central point over here. You can see over here that the arrows are coming from different directions, but they are pointing in one direction only. They are coming from all places. These arrows, we can see they are coming from everywhere, but where are they going? They are going to one place, and that one place is the one center point. Okay, so this is the convergent movement or convergent circulation. And divergent circulation is the complete opposite of the convergent movement. Over here, we can see that in this diagram, in this E stage or E circulation, that is labeled by E, you can see there are different arrows which are pointing into different directions. Okay, their origin place is one. That means there is one center point from where they are originating, but they are going into different directions. Okay, they are pointing outwards and they are going into different directions. This is the meaning of divergent. Okay, they start from one point and go everywhere, but in convergent, what is happening? They are coming from everywhere, but they are going towards one center point. Okay. Now, deformatory circulation. This is one type of circulation which sets the stage of the formation of the fronts. Okay. Now, there is this axis of inflow and axis of outflow. This is of importance over here, that axis of inflow is shown, but outflow is not shown in the diagram. But there are two axes. One is the inflow axis and outflow axis. So the airs are converging and diverging on the basis of temperature differences that are happening, creation of fronts that is happening over here. Okay, in the deformatory circulation. Okay, now classification of fronts. This is important because how do we classify a front? Okay, we should know that there are four types of fronts which are of prime importance, and a lot of climatologist scholars, they have identified four major types of fronts. Okay, so these fronts, they are having different characteristics. Okay, and they lead to different weather phenomena as well. There are certain weather phenomena which is associated with different types of fronts. So when one type of front is formed, it will have a different set of weather conditions accompanying it, and when another type of front is formed, it will have another type of or another set of weather conditions which is accompanying the front. Now, when I'm talking about stationary front, what I'm trying to, or what I'm trying to convey to you is that these fronts, that these stationary fronts, these are formed when two air masses of different nature, of opposing nature, of contrasting nature, when these two air masses, they come together, they come face to face with each other, neither of the air mass is able to push one another. So there is no struggle between the two. There is no competition between the two. There is neither of the air mass is trying to occupy each other's position or each other's area. So there is no struggle ensuing between either of the two air masses. So that is why this, in the stationary air front, we can see that no major climatic conditions or weather phenomena are taking place, because there is no displacement, there is no movement, there is a normal flow of air, movement of air that is happening. The winds are blowing parallel to the front. Okay, so a lot of weather phenomena, cloud formation, condensation, heavy downpour, precipitation, all of that is not happening. Okay, so cloud cover and precipitation is, even if it is happening, it is very negligible, and generally it is not happening, but even if it is happening, it is very negligible. So there is, whenever there is front formation, whenever there is stationary front formation, there is neither forward movement of the front nor backward movement of the front. This is the diagram of the stationary front. Over here we can see both the air masses are coming together. This is the cold air mass, this is the warm air mass, shown by red color. Cold air mass is shown by the blue color, and both of them are coming together with each other, but there is no struggle between the two, right? Cold front. Cold fronts are formed by cold air masses. And it is important to know that front is a boundary zone which is sloping, which has a sloping nature or a slanting nature. Okay. And when I say cold front, that means the cold air is more dominant over here. Cold front is formed by cold air mass, and in this case the cold air is very dominant. The cold air is trying to occupy a supreme position. Okay, and this cold air is having one tendency of settling down. It is already discussed with you. Cold air is heavy, cold air is having a higher density. Cold air tries to settle downwards, move downwards. Cold air has a settling down tendency. Cold air exerts a higher pressure on the surface of the earth. So what is happening is that in this cold air, it tries to stay near the surface. And because it is trying to stay near the surface, near the ground surface, so there is all type of friction that is acting over the cold air. Now, what type of friction? Friction, I can tell you, whenever you are driving a car or a motorcycle, what you are trying, whenever you are on the road, then the tires are in constant motion, fine, and they are rubbing against the surface of the road. Now, when you apply brake, what happens? The vehicle comes to a stop. Okay, your car or your motorbike, whatever it is, it comes to a stop. And when it comes to a stop, how does it come to a stop? Because it was in motion earlier. So when you applied the brake, there was a friction that was created between the tire and the road surface. Okay, so the tire and the road surface, they are having a friction between the two. Because of this friction, there is a tendency of slowing the movement or coming to a stop. Fine. So the force of friction is important to bring things to a stop. Okay. So this cold air, as it is flowing near the surface of the earth. Okay. So some places there will be all types of physiography, effects of topography that will be acting on the cold air. That is why there is more friction of the surface of the earth with the cold air. Okay, so when I'm referring to physiography, basically I'm trying to tell you that there are mountains, there are hills, there are plateaus, there are plains, there are fields, there is ocean surface, sea surface. So all these types of surfaces that are present on the earth, they are in constant rubbing against the cold air. Okay, so they can also act as, some places, the mountains, they can act as a barrier. Fine. So there is this force of friction that acts on the cold air. That is why there is less movement in the cold air, because she tries to bring things to a stop, or it reduces the speed of the of whatever is in the matter. It can be air, it can be vehicle, it can be automobile, anything. Okay. So okay. Now this force of friction is actually air. Fine. So now this cold air, it leads to formation of cold front. And cold front, and with the cold air, it becomes active. It becomes active that it tries to force its way into the area of the warm air. Okay, and it tries to become more dominant, so powerful, so supreme, that it tries to cover the entire area occupied by the warm air, and then it pushes the warm air upward, because warm air as it is, it has the tendency of upward movement because it is light in weight. So what happens is that it starts rising, and it starts rising very quickly. Okay, and because of this quick rise of air, there is, what happens is that the the excuse me, the warm air, this starts rising, and then there is um, the process of condensation which is happening. And this process of condensation leads to the cloud formation, and finally there is rainfall or snowfall or precipitation, if we have to say. In this diagram, this will help you to understand the cold air, the front that is formed by the cold air. This blue color you can see over here, this is the cold front. It is formed by the cold air which is flowing in this direction. These arrows you can see, they are denoting the cold air movement. Okay, and when it is coming in contact with the warm air, this portion is having the warm air. Okay, and this red color arrow you can see over here, it is moving upward. See, it is pointing upward. This red color arrow is showing the presence of warm air. So over here it is rising upward, and because of its constant movement upward, after it reaches a particular height in the atmosphere, it leads to the formation of clouds. Okay, there is the process of condensation happening over here. And then finally, these clouds become so thick, so heavy, so black and dark in color that they are known as cumulonimbus clouds. Okay, and cumulonimbus clouds are famous for heavy downpour. Okay, they are thick, dark, black clouds which are very nearer to the surface of the earth, and because of their nearness, because of their heavy weight, they are not able to sustain the moisture content in that manner, and that is why they are showering, they are shedding the moisture. These clouds, they have to shed the moisture in the form of precipitation. Okay, sometimes this precipitation can even be in the form of rainfall. So let us discuss the weather condition. Formation of thick cumulonimbus clouds. Thunderstorms happen, lightning also takes place, but this only happens for a short duration. There will be very heavy rainfall, but for small duration, very short period of time. Okay. And sometimes they are even accompanied by hailstorms. Hailstorms are, in Hindi we call them ole girte hain, jaise aasman se you can see small pieces of ice, they are falling from the from the sky, from the clouds. Small pieces of ice along with the rain, they are falling from the sky. So these are the weather phenomena that is accompanied by the that is accompanied with the cold front. Okay. Now warm front. When I'm talking about warm front, I'm basically trying to tell you that the warm front is formed by warm air masses, and these warm air masses are becoming dominant. In this case, the warm air it tries to occupy a dominant position. And the front that is formed by this warm air is not gently sloping. It has a steeper slope. The cold air mass forms a front which has a gentle slope, whereas the warm air forms a front that has a steep slope. Okay. Now this warm air becomes more dominant. It tries to enter into the area of the cold air, but because of its light weight, it is not able to completely occupy the area of the cold air, and it starts rising upward. Okay. And due to its rise upward, its constant rising, that causes cooling of the air. This is the adiabatic cooling of the air which is happening, and this cooling effect causes the air to become saturated, because warm air has a higher capacity to absorb moisture, but cool air has a lesser capacity to absorb and hold the moisture. Okay, so when this warm air, it starts rising. Let me show you over here. When the warm air starts rising, then what happens is that there is this creation of the warm front. You can see it is rising in this manner, and this front is also having a steep slope. Okay, now this constant rise leads to the adiabatic cooling of the air. Okay, and this cooling effect on the air leads to saturation of the air. Okay, saturation means already it had some moisture content, and because of its cooling effect, now it has become saturated. Now it cannot hold any more moisture. Okay, and now it is trying to shed the moisture. Fine, there will be condensation process. There will be cloud formation. There will be um, after the clouds become heavy with moisture, then they will shed the moisture in the form of precipitation. Okay, this is what I'm trying to explain you in this particular slide. Okay, so cloud formation happens, condensation happens, and finally precipitation happens. If the warm air is moist, then the condensation occurs at a lower height and vice versa. That means if the if the warm air is drier, okay, if it is less moist, if it is comparatively dry, then the condensation will happen at a higher height. Okay, if the air is moist, it will quickly become saturated because of the cooling effect, and it will not be able to hold the moisture for a long time. So it will need to shed the moisture, drop the moisture in the form of rain or precipitation. Okay. The weather that is associated with this is formation of thick clouds and condensation. Fine, definitely this we already discussed. Gentle to moderate precipitation. Now, when we talked about cold front, I was trying to tell you that the downpour, it happens, and it happens for a short period of time, but it is very heavy. But in the case of warm front, the weather that is associated with this is precipitation happens, but it is not for a short time. It is for a longer time. It continues to many hours. Okay, and because of this, it causes moderate precipitation. Okay, there is gentle to moderate type of rain or precipitation that is happening, but it continues for a longer period of time. The passage of the warm front is marked by a decrease in pressure, sudden rise in temperature, definitely, because the warm air is having that tendency of higher temperature, and wherever it will go, uh, it will lead to a rise in the temperature of that particular area, because it will warm air will come in contact with that area. It will tend to rise the temperature, increase the temperature of that area. Okay, and then there will be rise in temperature, there will be decrease in pressure, and the specific humidity will also change. There will be also changes in the wind direction and the temperature. Okay. Now let me tell you about the occluded front. Now when I'm discussing the occluded front, basically this is that time of the uh, that time of that stage of front formation, where the front is trying to now come to an end. Okay, now what happens is that the cold air becomes so dominant, and it occupies a supreme position. It occupies the entire area covered by the warm air. Okay, and the waves, the front, whenever the front is formed, it pushes the warm front, it pushes the warm air, the cold air pushes the warm front, and it pushes the warm air also. And the front generally bends. Now it was having a slanting position. Now it has started to bend. Okay, bend and form a wave-like structure. Okay, it has started to bend and it has started to form like a wave, like we see the sea waves, we see the waves are coming in the oceans. Similarly, the shape of the front becomes like a wave. Okay, and these occluded fronts, they are generally characterized by the cold air, which is more heavier. It tends to settle down, it pushes the warm air, it occupies the position of the space occupied by the warm air, and it pushes the warm air from below. Okay, now what happens to warm air? It starts rising, and it rises rapidly. Fine, with this rise of the warm air, it leads to it leads to I have already told you this. It leads to the rise in this rise of the warm air. It moves rapidly upward, and then there is the process of condensation, clouds formation, and precipitation. Okay, the weather phenomena. This generally happens in Western Europe, and this complete mixture of cold air and warm air. The weather conditions now, they are changing. Okay, this is also important from the cyclone point of view, because extratropical or temperate cyclones are whenever they reach the stage of the occluded fronts, that means the cyclone is now coming to an end. Okay. Okay, now there is a little note over here: cold front and warm front and occluded front. All these fronts are examples of temperature inversion. Okay. Now this is the diagram of the cold front. Basically, we can see cold air. It is trying to occupy the position of the warm air. See, it is narrowing down. The space occupied by the warm air is less, and space occupied by the cold front is more. Cold air is more, because it is entering into the space of the warm air over here, and it is shrinking the warm air. It is shrinking, that means narrowing down. It is decreasing the space of the warm air. Warm air, as it is being light in weight, it is rising upward, and there is cloud formation, precipitation, we can see in the diagram over here. And the cold air, now in this stage, it will completely occupy the warm air, the portion occupied by the warm air. So this is the occluded front. Now with this occluded front, I come to the end of the explanation for the chapter on fronts, air fronts. This frontolysis, we understood frontogenesis, we understood the characteristics of the fronts, we understood what are the different types of fronts, we understood in this chapter. And I hope it has been helpful to you, it has been of importance to you, it will help you gain knowledge and better understanding. Now I'll quickly move into the next chapter of climatology, that is the cyclone formation. Now cyclone formation is important from the point of view of the front, because if there are no fronts formed, then cyclones will also not be formed. So our chapter is extratropical cyclones, and these extratropical cyclones, basically they are forming in the temperate zone, they are forming in the middle latitude zone, they are forming in a manner in which there is a lot of turbulence happening. Why in the middle latitude? They are generally forming in the middle latitude because of the because these latitudes are famous for mixing turbulent nature, okay, and there is the air masses that is coming from different directions, and there is convergence of the air masses, okay. Now air masses, I told you, they are rising from the high pressure belts like the subtropical high pressure belt and these polar high pressure belt, okay. So polar high pressure belt will lead to the formation of an air mass which is cold in nature, which has a cold characteristic, or it has a low temperature. Similarly, the air mass that is coming from the warmer climate, that is the tropical climate, that air mass will have a warmer characteristic or a warm tendency, and it will have uh, it will it will be more have a it will have a higher temperature, okay. Now cyclones, they rise in the middle latitude region, okay. They are also known as extratropical cyclones. They are also the same cyclones have different names, okay, because they are originating in the middle latitude region. That is why they are also known as the mid latitude cyclones, okay, or the middle latitude cyclones. They are also known as temperate cyclones because the middle latitudes are also having a temperate type of climate. That is why they are also known as temperate cyclones, okay. In other words, they can also be known as wave cyclones. Wave, why? Because as I have just now told you, that when the when the cold air pushes the warm air, and there is a bend in the front, there is a change in the shape of the front, and it uh, instead of becoming sloping, it becomes like a wave, okay. So that is why they are known as wave cyclones also. They are sometimes known as depressions, troughs, and lows. Okay. Now, where does the middle latitude exist? The middle latitudes generally are found from 35-degree latitude to 65-degree latitude, north of the equator and south of the equator. That means in the northern hemisphere as well as in the southern hemisphere. So this is both the hemispheres. 35 to 65-degree latitude is of importance because in both the hemispheres, this region is the middle latitude or the temperate zone. Now the middle latitudes, they are turbulent. Why they are turbulent? Because there is constant mixing of the air masses coming from the polar area and from the tropical area. That means constant mixing of the polar air, cold air, and tropical air, that is warm air. That is why there is so much of mixing, so much of turbulence. This creates the conditions for the formation of the cyclones. The cold air is dry because it is coming from polar area. It is comparatively dry. It is not always dry because it can also be of maritime origin. So it can be comparatively dry as compared to the tropical air. If the tropical air is coming from the maritime region, then it will have more moisture. Why? Because warm air has higher capacity of absorbing moisture, whereas cold air has lesser capacity of absorbing moisture. So the cold, dry polar air moves downward because of its heavy weight, because of its density, it tries to move downward and it converges with the warm air. Okay, and the warm air has a tendency to rise. So little movement from the cold air, little movement from the warm air, both of them converge, both of them meet. There is a formation of a front, the warm air front and cold air front, and this leads to the generation of the cyclones. Generally, the cyclones move in an easterly direction. Okay, there are three distinct categories into which the cyclones can be categorized. They are the dynamic cyclones, thermal cyclones, and secondary cyclones. The characteristics of the extratropical cyclones. Now, this is of importance over here. Let's say the word characteristics of the extratropical cyclones. Okay, now these cyclones can be of varying sizes, shapes, velocity, and size and extent. Okay, they have a different diameter. Definitely, the cyclones can be large in size, small in size, medium size. Okay, they can also cover a smaller area, larger area, depending upon their size. If it is a large cyclone, it will cover a larger distance. It will occupy more space. Larger cyclone can be of 2000. It can cover a distance of 2000 kilometers. Okay. And if it is a small cyclone, maybe it can extend up till a distance of 500 kilometers. So they also have a height. Definitely, cyclones also have a height from the sea level. If we start measuring their height from the sea level, we generally understand that they extend up to a height of 10 to 12 kilometers into the atmosphere. Okay, from sea level upward, if we start looking at their height, it can be up to a height of 10 to 12 kilometers. There is a difference in the average velocity of these cyclones. Definitely, some cyclones are slow moving, some cyclones are fast moving. Okay, so they have different speeds. Okay, so because they have different speed, they have different velocity. That is why this difference also exists in their nature. Now they always follow a path. Okay, the cyclones, they always follow a path in which they move. They have a specific road that they take. Okay, this road that they are taking, the path that they are covering, it is known as a storm track. Okay, now this is important because we should know what is the area that is taken by the, or what is the path that is taken by the cyclone. That name of the path is storm track. Where there is convergence of warm and cold air, northern portion records a lower temperature due to presence of cold polar air and in that portion and vice versa. Now, definitely there has to be a convergence of warm air and cold air. Only then the front will be formed and only then will the cyclone be formed. Okay. Now, wherever there is presence of warm air, the temperature will be high. Wherever there is presence of cold air, temperature will be less. Okay. So in that portion where the cold air is present, temperature is less and we feel more cold over there. And wherever the warm air is present, that portion is having a higher temperature. When these two contrasting air masses converge, the formation of a warm front, warm sector, cold front, and cold sector takes place. The cold front and cold sector is formed by the cold air mass, and warm front and warm sector is formed by the warm air mass. Okay, so you should be able to understand this now. Contrasting air masses, what does that mean? Okay, formation of halos around the sun and the moon results in the arrival of the cyclone. Now, halo is something like a small light that is coming from behind the object. Okay. Now, whenever I'm talking about halo, basically, it is something that is like a small light that is coming from behind the object. Now, in this case, the halo is formed around the sun or the moon. Okay. Now, the sun and the moon, it is like a small light that is coming. It is like a small circular halo that is formed around the sun and the moon, and this is generally formed by the veneer of the clouds. Okay, and this marks the, whenever this type of a situation, this type of a condition can be seen in the atmosphere, in the sky, then we are able to say that now the cyclone is going to arrive. Okay, now origin of the cyclone. There are 6 important stages of the origin of the cyclone. This is of importance over here because these 6 stages will help you understand how the cyclone is formed, okay, and how the cyclone is taking birth. Now, in this 6 stages, I will go through all these stages one by one so that you are able to understand. Formation of the second stationary front. Okay, then there is the incipient stage where the front is formed in the where the front is formed. It takes a, this is the second stage. It takes a wave-like structure because of the interference of the cold air with the warm air. Okay, we are trying to invade each other's territory. Then the third stage is known as the mature stage. Here the isobars start becoming circular. They come in close proximity to each other. In the fourth stage, there is shrinking of the warm front as the cold air advances and it becomes more aggressive. It begins to take over the warm front. Then in the fifth stage, the formation of the occluded front takes place, and this leads into frontolysis. This paves the path for the process of frontolysis to begin. Then the final stage where the cyclone comes to an end and it tries to, it fades away. It begins to fade away. I will explain to you the life cycle of the cyclone with the help of this diagram over here. Like in the first stage, I told you, this is the stage in which the stationary front is formed. And as I have already discussed in the previous chapter about the air fronts, what is happening in the stationary front? In the stationary front, there is no struggle between any of the air masses. They are flowing in their own directions, but there is, because they are having different nature, different temperature, different humidity. So that is why there is creation of the front, because they are opposing in nature. That is why a front has to be created over here. Now in the second stage, that is the incipient stage, we are seeing that this front, which was having this type of a shape, now its shape is changing. Now it is bending. It is bending in a manner that it is forming a wave. Okay, this you can see over here, cold air and warm air, how they are trying to invade each other's territory. They are in a constant, now they are trying to struggle with each other. They are trying to compete with each other. Over here, we can see the warm air and the cold air, and we can also see the cold front and the warm front. Fine. Now this warm front over here, we can see it is being pushed upward by the cold air, because the cold air has become dominant over here. The isobars are trying to become more circular and close to each other. These are the isobars. They are trying to come in close proximity. So this is the cold air and it is trying to push the warm air. It is trying to occupy the position of the warm air, and the warm air is being pushed upward, and this upward movement of the warm air will lead to condensation. It will lead to creation of clouds and precipitation. Okay. Now over here we can see in the fourth stage of the cyclone, life cycle of the cyclone. In this fourth stage, the isobars are coming even more closer, okay, and the cold air is becoming completely dominant. There is shrinking of the warm air. See, over here there was more area occupied by the warm front, and over here there is a narrowing down of the warm front. There is lesser area for the warm air to occupy now. And over here, the cold air is becoming dominant, covering a lot of area. It is trying to occupy the warm air. It is trying to push the warm air upward. Continuous struggle between the two. Now, in the fifth stage, the occluded front has started to form. Okay, occluded means to come to an end. Over here, there is this movement of the air which is happening. And see how the warm front is now coming to an end. The warm front is now cold air. There's only this large area occupied by the cold air, and the warm front is trying to wither away. It is dissipating now. Okay, it is weakening now over here, and there is this movement of air in this direction in such a manner that it is completely taking the space of the warm air. Over here, in the last stage, when the occluded front has also formed and the process of frontolysis has now begun, and there is this complete disappearance of the fronts. There is no front that can be seen now, only the cold air and the warm air that is flowing over here. Fine. So now the conditions have started to normalize. The conditions have started to, again, because there was a lot of whirlwind, there was a lot of circulation, quick movement, fast movement of winds within each other, and there was so heavy downpour and a lot of cloud formation. There was rainfall associated with different fronts, movement of the different fronts. Okay, so now after the cyclone has come to an end, everything has come to a stop. Okay, now there is no movement, no fast moving winds, no veneer of clouds, no halo formation, no front formation. It has come to an end. The winds have also started normally blowing. Okay, this is the life cycle of the cyclone. Now, there are different impacts of the cyclone which we can see on our daily lives. There are the cyclone causes a lot of destruction. That is why it is an unwanted phenomena of the atmosphere. But because of the opposing nature of the winds, and there is constant movement of the winds from the high pressure area to the low pressure area, so the front formation is a continuous process. It is like a cyclic process. It has to happen. There is no escape from it. But the cyclones can be of different impact, different speed, different sizes. They can be long. They can be elongated. They can be radial. They can be of polygonic type. So these are the different types of shapes of the cyclones, and the impact is generally of a destructive nature. So when I say destructive nature, there is loss of human life, loss of property, destruction of the fields, destruction of the crops, destruction of the office buildings, residence buildings, important structures, monuments, inundation of the land, because whenever the cyclone hits, that time there is a lot of rainfall, there is inundation, there can be flood situation also. Okay, so the impact of the cyclone can be disastrous. This is the entire information that needs to be given to you for fronts, for air masses, and for the extra tropical cyclones, the temperate cyclones, how they are formed. Okay, I hope it has been of significance to you. It will help you in better understanding. I wish you all the best and take good care of yourself. Thank you. I end my lecture over here.